RIT just proved Einstein right.
Go Tigers! This is Space News. What's up, everybody? Welcome back to another episode of Space News, reporting live from our Emergency Science Bunker, sponsored by RIT.
We're still here.
We're still here. But it's exciting because we are at RIT, and they helped with the determination of the source of gravitational waves, which we have finally detected, thanks to LIGO.
No longer just this mathematical expectation that Einstein came up with. They are now an observed scientific fact. And RIT provided some of the templates that they used to match with the signal to figure out what was going on.
Right, so LIGO, the Laser Interferometer Gravitational Wave Observatory, say that 3 times fast, actually detected 2 blips, chirps. They call them chirps. And in order to actually determine what they are, you have to match them up just right with the simulations that people at RIT, not Kevin or I,
not me,
not us,
no.
Actually created. So they throw black holes at each other, basically get that little wiggle down from the space-time wiggling out, gravitational waves, not gravity waves, gravitational waves, and we compare that wiggle to the wiggle that we see from LIGO. And lo and behold, we got 2-ish detections, which is awesome.
And these detections have actually opened a new door onto other parts of science. The first detection was a merger of 2 black holes that were about 30 times the mass of our sun each. And the thing is, no one really knows how to make black holes that big using stars. So now the stellar community is working very hard to determine what kind of environments can you build these things in.
Right. So probably some sort of binary merger situation. Maybe these are already part of a collision.
Many small black holes adding up together.
This could be helping out with the hierarchy theorem for how galaxies and black holes are formed. This is opening a whole new can of worms. It's exciting stuff.
And so now the new buzzword is multi-messenger astronomy. So as more gravitational wave detectors get built, they'll be able to do a better job of pinpointing where they came from in the sky, and then using regular telescopes that see light to follow up and see if we can see anything with light emitted from whatever kind of collision or merger may have happened.
Right, so we get that extra bit of confirmation, so we actually maybe visually see what's going on there. And LIGO isn't the only thing that's out there trying to detect gravitational waves. LISA Pathfinder has had some success lately on determining that it's actually pretty easy to do it in space.
Right. The ESA, the European Space Agency, built LISA Pathfinder, so it's just an engineering test to see how well you can measure distances using lasers in space. And they need to do this if they're ever going to make this giant 3-satellite array that could detect gravitational waves.
Right, so one problem with things being on Earth, especially when you need such tiny measurements, is a gravitational wave detector is a laser that hits a mirror and comes back. So if you have any disturbances, basically from anything on the planet Earth, that could get in the way and make noise for your data. But in space, you don't have the Earth to get in the way and make all those vibrations. So that's why we're hoping that in the future, things like LISA Pathfinder will help us build these space-based interferometers to detect more gravitational waves. It's exciting stuff. Seriously, it's like a whole
dawn of a new age.
He just said the whole buzz phrase, dawn of the new age. Ugh, makes me sick. But it's exciting stuff, especially for RIT Tigers. Go Tigers. So hopefully there'll be more coming out of that sometime soon. Maybe we'll cover it. I don't know. This could be the end of our special series event. We could be back for more. Stay tuned. That's why you have to subscribe.
Like and subscribe below.
Yeah, what that guy said. Thanks for watching.
Thank you.
And we'll see you out there.
Thank you for watching. Marcus and I return to YouTube during this limited series. If you liked what you saw, please like, comment, and subscribe below. And make sure to comment if you have suggestions on what kind of content you'd like to see for any additional limited series runs we may do in the future. Thanks again.